3. Today we'll be doing partial fraction decomposition. So that's a pretty intense vocabulary word there. So let's highlight this. Partial fraction decomposition, that's what we're doing. So essentially what we're doing is we're getting this fraction and we're trying to decompose it into its basic form. So we want it to look like something like this. A over x minus 4 plus b over x plus 2. So essentially we're trying to undo whatever put these two things together to get this. So the method I'm going to show you is called Equating Coefficients. And luckily we've actually done something similar in the more advanced problems earlier in the year. So this shouldn't be too difficult for us. What we're going to do is imagine you have this whole thing here. We want to get the common denominator. So we're saying these two things are equivalent. So think, what does this fraction need? I can see that fraction needs an x plus 2. So I'll put that on top and bottom. And I know the right one needs an x minus 4. So I put that on top and bottom. Now, notice how the denominators are all equivalent, which means I can write the numerators. X plus 14 should equal a times x plus 2 plus b times x minus 4. Now from there, we're going to multiply it out. X plus 14 equals ax plus 2a plus bx minus 4b. And what's important here is we're not solving for x. We are doing this, equating the coefficients. So what we're doing is we're actually comparing. I'm going to underline everything with an x in it. And we're saying that these things all must be equal. So look at the coefficients. This is saying 1x has to be equal to ax plus bx, which means a plus b must equal 1. Now I'm going to circle all the numbers. I have 14, 2a, negative 4b, which means 2a minus 4b must be 14. And now look at this. I have a very nice system of equations. So I'm going to multiply this equation by 4. So now I have 4a plus 4b equals 4. 2a minus 4b equals 14. Let's cross that out. So 6a should equal 18. A is equal to 3, which means b must equal negative 2. Now it's important to remember that this is not the final answer. We're trying to decompose the fraction, so we're trying to get to here. So simply plug in a, plug in b. So the partial fraction decomposition is 3 over x minus 4 plus negative 2 over x plus 2. That right there is your answer. Which means if I told you to combine these two, like you did in Algebra 1, the outcome would be the original problem here. So now let's try a harder one. It says find the partial fraction decomposition of x minus 18 over x times x minus 3 squared. And notice this piece right here. There's a repeated linear factor. What that means is we see this x minus 3 quantity squared. Now the way we're going to handle that is essentially think of it as 3 factors. So we have a over x. This is the first linear factor. And then b over x minus 3. That's this one. And then you have to consider the possibility that x minus 3 squared is also a factor. So notice how there are actually 3 pieces here. So with the repeated linear factor, you just have to account for each piece. So notice how this is the first power, that's second power. So had this been like to the third, we would introduce a plus d over x minus 3 cubed. But that's not the case, so we'll get rid of that. Now once we've done this, the steps are quite similar to what we did earlier. You look at each piece and think about what it needs. So the first thing needs an x minus 3 squared, top and bottom. The second one needs an x and an x minus 3 to top and bottom. And the last part just needs an x. So once I multiply that in, I'm going to rewrite only the numerators. So I have x minus 18 should equal a x minus 3 squared plus bx times x minus 3 plus cx. Now let's just work it out. That's a x squared minus 6x plus 9 plus bx squared minus 3b plus cx. Oh, 3bx there. Let's go a little bit further with our algebra. Ax squared minus 6ax plus 9a plus bx squared minus 3bx plus cx. And again, we're going to equate the coefficients. So that's the key here. Equate the coefficients. So look at your x squared terms first. Notice how there is no x squared term here. So think of that as like plus 0x squared, which means a plus b must equal 0. Now I'll do the x's. I have an x here, x term here, and x term here, and the x term here. So quite a bit. So that's going to be negative 6a plus minus 3b plus c equals 1. And I'll circle the constants here. That's a really good one because now I have 9a equals negative 18. And now we solve. So looking at this is pretty easy to solve. We can see that a must be negative 2. And if a is negative 2, a plus b is 0. So b should be positive 2. Plug it into this third equation. So we get 12 minus 6 plus c should equal 1. So c should be negative 5. So there's our 3 variables. Now we plug them back in. Negative 2 over x plus 2 over x minus 3 plus negative 5 over x minus 3 squared. And there it is, partial fraction decomposition. Now we're going to do these. So this is a great example of, we're just going to do the setup. The setup is referring to this step we've been doing, this like a and b, a, b, c over here. So for this one, let's first factor that. That would be x minus 6 times x plus 1. So the setup would be a over x minus 6 plus b over x plus 1. Of course, it doesn't matter if these are switched. This is the main thing. Now this one's a bit tricky. I can see that this is factorable, but then I have 2 repeated linear factors. So really we want to consolidate now to get this. So that's a little bit tricky. So now I can have a over x plus 2 plus b over x minus 2 plus c over x minus 2 quantity squared. And here's our last one. This one is again tricky because we clearly see a repeated linear factor here, but this right here is also a repeated linear factor. So we're going to write a over x plus b over x squared plus c over x minus 4 plus d over x minus 4 quantity squared. Yep, and those are the solutions for that. Notice how I put a big note, do not solve. So also I'll put problems like this on your test or quiz, just to test if you can set it up properly. The last thing I want to discuss with you before you work on the problems is this note. Let's say you get a fraction, like a is equal to 2 over 3, and you have like a over x minus 4. the way you plug it in is you'd write 2 over 3 over x minus 4. So we can see our substitution, but you can't leave it as a complex fraction. So what happens is it just becomes 2 over 3 times x minus 4. So essentially, you can think of this thing as 2 over 3 times 1 over x minus 4. That's the same thing. But you'll have to leave it like this. This is not simplified because you can't have a complex fraction here. So this would be our final answer. So this is what you do in the event that you do get a fraction.